Hello, this is Mr. Tipton, and today we are talking about changes in scale. Perimeter, area, surface area, volume. We're just looking at, if and when the side lengths, if they change, if they're doubled or tripled or halved, two figures, how many times greater is the volume of this one versus the volume of that one. Okay, but the changes in scale between two figures is what we're going to get into. That's kind of a confusing way to start the video, but it's going to be clearer as we get into this. First, just a quick review. Here we have perimeter, area, and volume. Perimeter, I just want to be sure that we understand that perimeter is one-dimensional. Okay, if I was going to find the perimeter of this rectangle here, I would be looking at, the outside. Just one-dimensional would be the top plus the right plus the bottom plus the left. The perimeter is just length around a figure. And so if this was, let's say, 3 inches, okay, then my label for this would be in inches. Okay, just one-dimensional inches. Whereas area, when we find area, we're actually figuring out how many squares are inside something. And so this is a two-dimensional. The area is two-dimensional. So whatever the area was, it would be x, and we would call it square inches. A lot of people say inches squared. I prefer square inches. Right, inches to the second power. Volume, of course, is a three-dimensional thing, and I don't know how I'm going to draw this here, but it's got length, width, and height. Yep. Oh, that's a mess. But basically, we're looking for how many cubes fit inside an object. It has length, width, and height, not height. Three-dimensional, it's inches cubed. Whatever the volume of this shape is, we would say it's 100 inches cubed. Alright, volume is three-dimensional, area is two-dimensional, and inches is one-dimensional. There's only one way it can be measured. That's going to be important for us figuring out what our changes in scale look like. Alright, here's what I'm talking about. The way that we are going to figure or calculate our changes in scale is we're going to use powers, okay, exponents. The base of our exponent, our big number, remember, the 4 is the base and the 3 is the exponent. Write that down here. The base is going to be our change in scale. And the exponent are going to be the dimensions of the figure that we're talking about. It doesn't make any sense yet, but it will when we get into our examples. Remember, base is your change in scale, and the exponent is the dimensions. Here we have a rectangular prism, and says if the side lengths are tripled, describe the change in volume. Okay, we could figure out the volume of this figure. Let's see, length times width times height, we'd have 3 times 5 times 5. So this one would actually be 75 cubic inches. Remember, it's volume, so it's cubed. And, we could follow the directions. If the side lengths are tripled, that means 3 times 3 is 9. This would be 15. And this one would also be 15. Okay, and if we work this out and did length times width times height, well, 15 times 15 is 225, and 9 times 225, I think, is 2025 cubic inches. Okay, and what we're going after here is we're being asked to describe the change in volume. What we want is how many times greater or less is the new figure than the old figure. Okay, so to figure this out, we would take the 2025 and divide it by 75, and that comes out to 27. Okay, so when you triple all of the side lengths, the new figure is 27 times greater, or the volume is 27 times greater than the original figure. Now, that's the long way to figure this out. Okay, remember what we saw on the last screen. The quick way, the easier way to figure this out is, what is our change in scale? Well, that's right here. All the side lengths are tripled, so that is going to be the base of our exponent. And because we are working with volume, that is a three-dimensional figure, that means our exponent is 3. Okay, 3 to the third power, 3 times 3 times 3 is 27, okay, which is what we got here when we did it the long way. Okay, the new volume, that says the new volume is 27 times greater. Okay, that's the change in scale when you triple all the side lengths of this rectangular prism. Let's look at another one. It says if the side lengths are doubled, describe the change in surface area. I'm not even going to bother doing this the long way again, where we find the surface area of this and we double all the sides and we find the surface area of that and then we divide. We don't have to do that. The change is that everything's being doubled, so the exponent is 2. And because we're talking about surface area, area is two-dimensional, so 2 to the second power is 4. The new surface area, I'm going to abbreviate, the new surface area is 4 times greater. That's all there is to it. Example 3, if the side lengths are tripled, describe the change in area. Okay, again, the fact that it's 5 by 5 is great. I could do 5 times 5 is 25, and I could triple both of those and I'd get 15 and 15, which is 225, and 225 divided by 25 is 9. 9 times greater. I mean, that's right, that's the answer. You can do it that way, but just use the change in scale, which is tripled, gives us a 3, and its area, which is two-dimensional. 3 squared is 9. Okay, same thing, but a lot easier way to get there. The new area is 9 times greater. That's a 9, by the way. 9 times greater. Alright, one more. We've done volume, we've done surface area, we've done area. Now we have perimeter. And it looks like we are going to double the side lengths for perimeter. Okay, so the change in scale was 2. Perimeter is one-dimensional. 2 to the first power is 2. So the new perimeter will be what? New perimeter will be doubled. Will be doubled. Or you could say twice as much. Twice as much. Or the new perimeter is 2 times greater, like we have been doing. 2 times greater. Alright, I was just kidding. We actually do have one more. This last one's a little different. It says if the length is doubled and the height is tripled, describe the change in volume. Okay, here we have different things happening to the different side lengths. Doubled times tripled. That's what's happening right there. The new volume is 6 times greater. I really don't want to show you this the long way, especially with a 68, an 81, and a 74. No thanks. But as you can see, we've got the doubled and the tripled. 2 times 3. New volume is 6 times greater. We don't have to worry about the exponent here because the same thing is not happening to all the sides. One side is doubling, one side is tripling, the other side is staying the same. So we've got a 2 times a 3 times a 1, really, which is 6. So 6 times greater. Pretty easy, pretty straightforward. If you have any questions, be sure and write them down, and we'll see you soon.